Greetings, lovers of mysticism and the unknown. Welcome to the Incredible Stories channel. We are explorers of the unexplainable and unbelievable. Today, I will tell you an interesting story. Brew up some goodies and enjoy. A model Renaissance man. Leonardo da Vinci was an artist, scientist, inventor, and genius who left behind a legacy of discovery and innovation that is still admired today. And if the authors of a recently published study are right, Da Vinci was even wiser and more insightful than previously thought. According to the researchers, Da Vinci left a number of notes and sketches in his collection of papers, which prove that he comprehended the fundamental aspects of gravity centuries before Isaac Newton was born. A team of scientists led by Mori Gariba, professor of aeronautics and medical engineering at the California Institute of Technology, Caltech, presented the results of their research into Da Vinci's theoretical deductions on gravity. They described how Da Vinci's drawings depicting a science experiment that he imagined but did not perform sparked their interest and allowed them to discover how much he knew about gravity and how it actually worked. The drawings showed a jug of water moving through the air in a straight line, with sand-like particles spilling out of it and falling to the ground. Some drawings showed the water jug moving at the same speed, while others showed it accelerating at a constant speed, with sand particles falling out in each scenario. In his notes, Leonardo tracked the supposed changes in the speed of the jug as it accelerated, as well as the changes in the speed of the sand particles as they accelerated on their way down. Da Vinci's last action was incredibly important and groundbreaking because it meant that he recognized the force of gravity as a constant force of acceleration. He knew that gravity makes a falling object move faster and faster until it hits the ground and its motion stops. This was a great leap forward and a vital first step toward understanding how gravity works and how it affects all physical objects everywhere. But Da Vinci's genius didn't stop there. In the course of his experiments, he discovered something more specific that brought him one step closer to a fully developed theory of gravity. Leonardo da Vinci's drawings, published in a collection of his works called the Codex Arundel, included triangles that he created by drawing lines tracing the movement of a jug of water and various falling particles. Depending on changes in the speed of the jug, differently shaped triangles were produced, and it was the drawing of one such triangle, as well as the accompanying inscription, that caught Mori Gariba's attention when he used the Arundel code as a source for a graduate course he was teaching. What caught my attention was that Leonardo had written equation de moti, equation or equivalence of motions, on the hypotenuse of one of the triangles he drew, one that was isosceles and rectangular. Gariba said in a Caltech press release, "I became curious to know what he meant by that phrase." To explore Da Vinci's ideas and discoveries in more depth, Gariba enlisted Caltech PhD Chris Rowe, now an associate professor at Cornell University, and Flavio Nock of the University of Applied Sciences and Arts of Western Switzerland in Geneva to help examine Da Vinci's drawings and notes more closely. Noca helped translate Arundel's codex, and by working together, the team eventually discovered how far Da Vinci had come in his understanding of gravity. In addition to recognizing it as an accelerating force, they also found out what Leonardo meant when he wrote the phrase equation de moti. Da Vinci seems to have guessed that when the motion of the jug is accelerated according to the rate of gravitational acceleration acting on the particles, the result is a perfectly balanced equilateral or right isosceles triangle. This is important because Da Vinci reached the stage where he was ready to calculate the gravitational constant, an important quantity needed to create a complete theory of gravity. He used geometric reasoning to reach this understanding, after which an attempt to determine the actual mathematical value would be the next step toward a theory of gravity. Unfortunately, Da Vinci made a few mistakes when trying to calculate the constant. Caltech researchers were able to identify them in their transcription of his work. But even here, Leonardo's efforts were impressive, as he ended up with a figure that was about 97% accurate. All in all, it was an incredible work that anticipated the labors of other intellectual giants. Leonardo da Vinci, a man 500 years ahead of his time. Leonardo da Vinci died in 1518, 125 years before Isaac Newton was born, and 169 years before Newton published his mathematical beginnings of natural philosophy, which presented his laws of universal gravitation. If the mathematicians and scientists living in those years had known about Da Vinci's discoveries, like Galileo, who knew something about the subject, perhaps they could have developed his work and created a complete theory of gravity long before Newton eventually did. But Leonardo's work in this area seems to have been somehow overlooked. We don't know whether Da Vinci did further experiments or explored the question in more depth, Gariba said. But the fact that he dealt with the problem in the early 1500s demonstrates how far forward his thinking was. So far that the fruits of his labor remained unrecognized and unappreciated until the 21st century, more than 500 years after Da Vinci came so close to uncovering the whole truth. What did you think of it? Write in the comments. Be sure to get likes, subscribe to our channel, and check out other amazing stories.